Hello everyone. Today I'd like to introduce to you the model of PIE SAR, polarimetric SAR. The Polsar model includes function of polarization synthesis, Polsar basic change, polarization signatures, as well as polarization synthesis, Polsar metric conversion, Polsar filter, Polsar decomposition, and RGB channel synthesis function. Next, we introduce the process of polarization decomposition. The polarization scattering metric is used to reveal the scattering mechanism of scatter, which can effectively separate different surface features dimensioned by different scattering mechanisms. The polarization decomposition is an effective means for information extraction and target classification based on the target polarization characteristics. The polarization decomposition methods include free main decomposition, poly decomposition, HA alpha decomposition, Yamaguchi decomposition, and anion decomposition. We are using data with GF3, fully polarized GF3 data. By importing this data, the data are transformed into the SLC data of singular complex number after calibration, which is used as the input image of the later polarization decomposition. Firstly, we import GF3 and click on the Data Import module. GF3 is a multi-channel data. Metadata files, we find our data. Find GF3, load metadata files. After loading the metadata file, the data of several polarization modes can be loaded in, and then output the file, name it, click Save, click OK. Completed the import of data. Next, let's proceed the Polsar matrix converts. Polarized scattering matrix can be used to describe the coherent scattering or the pure scatter. For the distributed scatter, the polarized scattering matrix is usually transformed into the polarized coherence matrix with the second-order descriptor, which can be reduce the effect of the speckle noise. When convert a matrix of the polar scattering matrix imported from the previous step into matrix of the polarization covariance C3. So when we choose the looks, we choose a looks of 3 times 3. We open the function of polarization matrix transformation. When we input the file, we input the result of data import in the previous step. The transformation format is C3 format. If the city is selected, the transformation only be found between C3 and T3. And if the reciprocity is not selected, the transformation only be found between C3, C4, and T4. Because we want to select C3, so select the reciprocity option. Looks is selected 3 times 3. Then file output, file name, and then click Save, click OK. After the polarization matrix is converted successfully, click OK. Then we do the next step. Next, we do a decomposition. We choose Freeman decomposition. Freeman decomposition decomposes the polarization conversions matrix into 3 main scattering mechanisms: surface scattering, bulk scattering, and dihedral scattering. The input file is the result of our previous polarization matrix conversion, input format, we choose C3. This is to say, select the format for the output of previous step. The size of the window is based on the 3x3 window. You can check the stretch option. The stretch option is used to determine whether to stretch the output image, then output the file, name the file, click Save, and click OK. Successful polarization decomposition, click OK. Then the original data and the successful polarization decomposition data are loaded into the software for viewing. You can use the load swap function under display menu bar to help you view data. Then we choose another polarization method, purely. The purely decomposition decomposes the scattering matrix S into the weighted sum of the complex forms of each purely matrix. Each purely matrix corresponds to a basic scattering mechanism and has the property of keeping the total power unchanged. First, loaded the data. Same choice data after Polsar matrix convert. Input format selection C3. Select 3x3 for window size. Check the stretch option. Name the output file. Click Save. Click OK. Generated reflects odd and even scattering. Then, the result of previous step and purely polarization decomposition data are loaded into the software to view and make a comparison. Next, we choose the HA alpha polarization decomposition method as one of the third polarization decomposition methods. Based on the eigenvalue feature vector analysis, Cloud and Polsar propose three parameters such as polarization, entropy H, scattering angle alpha, and polarization anti-entropy A to describe the scattering mechanism of the feature. The lower the entropy is, the more certain the target is. The higher the entropy is, the larger that the target randomness is. In the same way, the data processed by polarization matrix transformation are added first. This step is mainly a polarization method based on the eigenvalue feature vector analysis. Propose three parameters such as polarization, entropy H, scattering angle alpha, and polarization anti-entropy A to describe the scattering mechanism of the feature. The lower the entropy is, the more certain the target is. The higher the entropy is, the larger the target randomness is. Click on the output file, name the output file, click Save, click OK. After processing, click OK. Then load HA alpha polarization decomposes the data to view. This is the result of HA alpha decomposition. Then we choose the next polarization method, Yamaguchi. In order to solve the problem of asymmetric scattering in urban areas, Yamaguchi interrogates the spectral scattering and the Freeman decomposition, which can be more widely used in the case of scatters with complex geometric scattering structures. In the input file, we also choose the polarization matrix transform data, C3 format, and the algorithm of Y40. The window size is 3x3. Check the stretch option, then output the file. Name the output file. Click Save. Click to determine. The polarization decomposition is successful. In order to solve the problem, asymmetric scattering in urban areas, Yamaguchi interrogated the spectral scattering and the Freeman decomposition, which can be more widely used in the area, which can be more widely used in the case of scatters with complex geometric scattering structures. Load the newly processed result into the software for viewing. This is the result of geometric decomposition. The last way we choose is ion polarization decomposition. Anvento has improved the Freeman decomposition in 2010. The method can process the directional angle of the coherence matrix before decomposition and adds energy constraint to improve the overestimation of volumes, current, and negative energy problem. Open the function, input the file, select the polarization matrix converted data, input format C3, window size 3x3, check the stretch option, output the file, name the file, click Save, click to OK. Load the processed result. This is the result of ion decomposition. This is the step of polarization decomposition we introduced to you. Thank you.